welcome to your class. Today we're going to be continuing with our complex numbers, and today we're going to be looking at powers and roots. Okay, so given a complex number, we're going to find its powers and its roots. Okay, so the objectives of this lesson, what we are going to learn is we're going to apply De Moivre's theorem to compute the powers of a complex number in polar form. Okay, so we're going to be working with complex numbers in polar form. Okay, so make sure you're able to change complex numbers to and from polar form. Okay, then the other thing is you're going to be finding the nth root. Okay, so given a complex number, you're going to find a square root, a cube root, and so on, the nth roots of a complex number. Okay, so roots, this means that we are going to have many answers. Okay, then the other thing, the last thing is we're going to visualize those roots. After finding the roots here, we're going to be visualizing them as regular polygons. Okay, so this is very interesting. A complex number has many roots and they form a regular polygon. Okay, so we're going to be finding those roots. After finding them, we're going to draw them as a regular polygon on the Argand diagram. Okay, so make sure you subscribe so that you don't miss the next interesting part of this lesson. Before we get in further, let's understand what is a polar form of complex numbers. Okay, so I think by now you know that polar form of a complex number is going to be important in this topic. Okay, so let's see, given a complex number is a number which has a real part and an imaginary part. Okay, so let's say you have a complex number a plus bi. Okay, you can say a plus ib. Okay, so this is a complex number. Okay, so changing this complex number to this form r cos theta plus I sine theta is what we call polar form. Okay, so if it is in this form, it is called to be polar form. Okay, so let's see what is r. Okay, so r is the modulus. Okay, so it is the modulus of this complex number. Okay, it is found by saying a squared plus b squared. Okay, it is very easy to find. Okay, so just say a squared plus b squared, you find your r. Okay, then after that you have to find theta. Okay, so theta is an angle which you call argument. Okay, it is measured in degrees or in radians. Okay, so this is an angle which we call argument. Okay, so theta, there is a process you have to follow to find this theta. It's very easy. I think I did a video where I showed you how to find argument. Okay, so but it's just an angle. Okay, so the first step of it is finding tan arctan b over a. Okay, arctan b over a. Okay, this will be the argument only if a and b are positive. Okay, remember, but there is a long step. Okay, so please go and watch that video where I talked about how to find argument. Okay, so this is what we call the polar form of complex number. Okay, so in this video I'm going to be shortening it as RCIS theta. Okay, so this is the way I'm going to shorten it. Okay, so this R is here, then cos I and sine, I'm going to represent it by sine, by this CIS, then theta is the angle, the argument here. Okay, so let's now get into how do we deal with it. Let's take a look at what we call the De Moivre's theorem. Okay, so you can pronounce this one the way you want. I don't know how exactly it is pronounced, but I say De Moivre's theorem. Okay, so it is for powers. Okay, so given a complex number, let's say z is equals to, okay, let's assume all complex numbers we are going to be working with are in polar form. Okay, so make sure you change all the complex numbers to polar form before you apply this theorem. Okay, so let's say you have a complex number z is equals to r cos theta plus I sine theta. Okay, so this is our complex number. Okay, so now the De Moivre's theorem says that if you are being asked to find z to the power n, okay, so this means that you are saying r cos theta plus I sine theta. Okay, all of this in to the power n. Okay, so the De Moivre's theorem have a way for you to simplify this. Okay, so what we have to do is you just have to take this power and power this modulus. Okay, so this becomes r to the power n. Okay, then after that, to this argument, you're going to say cos n theta. Okay, so you're going to be multiplying this n to the argument. Okay, the first thing you put this n to the power r to the power this n, then after that you're going to multiply this argument with this power. Okay, so this means that you're going to get r plus I sine n theta. Okay, so this is it on the De Moivre's theorem. Given a complex number in polar form like this, and it is raised to the power n, what you have to do is, let's write the steps here. The first thing is you have to raise the modulus to the power n. Okay. Okay, so after raising the modulus to the power n, well, the next thing is you just have to multiply the argument with n. Okay. Okay, so these are the two things you have to follow. Okay, so it is very, very easy. After changing this to polar form, your z, given your z in the form a plus bi, if you change it to polar form, you can easily find it to the power, I don't know the number. Okay, so what you have to do is you just have to say this modulus to the power n, and after that, you just have to multiply each argument with n. Okay, so this is it on finding the powers of complex numbers using the De Moivre's theorem. Okay, so this is it. Now let's look at how do we find the roots. Now let's find the roots of a complex number. Okay, so let's say you have a complex number. A complex number you are given z is equals to a plus bi. Okay, so your first step is to change this complex number to polar form. Okay, so make sure you remember that you change this complex number to polar form first. Okay, so after changing to polar form, it becomes a complex number like this. Z is equals to r cos theta plus I sine theta. Okay, so after this, this is where you can find its roots. Okay, so the first thing you have to do, let me shorten this so that we can make it easier. Z is equals to r cis theta. Okay, so I just shortened it to become this short one. Okay, so what you have to do when you ask to find the nth root of z. Okay, so this is the nth root of z. Okay, so let's say there is n here. Okay, so what you do, the first thing is you just have to say r to the power 1 over n. Okay, this is the first step. Given you want to find the nth root of z, the first step is to say r to the power 1 over n. Then after that, you're going to say, let me use CIS for this. Then you're going to say theta plus 360k over n. Okay, so this is what is going to happen to your argument. You're going to be using this formula to find your argument. Okay, so in this case, you see r is our modulus, theta is our argument, then n is the nth root we are supposed to find, then k is the whole numbers. Okay, so k is from 0, 1, 2, 3 until you reach n minus 1. Okay, so you can see that here we're going to be substituting k is equals to 0, then we get our answer. Then the next answer we're going to substitute k is equals to 1, then we get our answer, and so on and so on and so on. Okay, so this is it. This is what we're going to do. Okay, so this means that for a complex number to find the nth root. Okay, so let's say the fourth root. Okay, find the fourth root of this. You're going to get n solutions. Okay, so this is what we have to remember. For a complex number, it's being said find the nth root of this. You're going to get n solutions. Okay, so to find these n solutions, you're going to be substituting k is equals to 0, k is equals to 1 until you reach n minus 1. Okay, so this is it on finding the roots. Next, we have an example where we are going to look at this. Okay, so make sure you're in touch and you don't miss it. Okay. Okay, let's take a look at the first example of our lecture. Our first example is saying that find 1 plus I to the power 6 using De Moivre's theorem. Okay, so this is our example first. So what we're going to do first, we're going to let Z is equals to 1 plus I. Okay, so let's say this one is our complex number. So we are being asked to find Z to the power 6. Okay, so I remember I said the first duty is to change this one to polar form. Okay, so how do we do that? The first thing is you just have to find the modulus of Z. Let's say this is A plus BI. Okay, so you can see that in this case, our A is 1 squared plus, then B is 1 again, so it's 1 squared. Okay, so this means that we're going to get root 2 as our modulus. Okay, so after finding our modulus, we just have to find the argument. Okay, so our argument, we just have to find alpha first. Finding alpha first, we are going to say arctan b over a. Okay, so in this case, you can see that b is 1 and a is 1. Okay, so it's going to become arctan 1 over 1. Okay, so in this case, you're going to get 45 degrees. Okay, so this becomes our answer. Okay, so this is our alpha. Now let's take a look at an Argand diagram. This is a simple Argand diagram. This is a real part and this is our imaginary part. You can see that 1 is somewhere here and 1i is somewhere here. Okay, so this means that we're going to have our argument as this angle. Okay, so this angle is 45. So measuring it from the positive axis, it becomes 45. Okay, so this means that argument of z is equals to 45 degrees. Okay, so it's easy that if you didn't understand this short process, please go and check my video where I talked about how to find an argument. Okay, so this is it. Now this means that our complex number z is equals to root 2 cos theta, our theta is 45 plus I sine theta, our theta here is 45 again. Okay, so this is it. This is our complex number. Okay, so let's shorten it to become root 2 CIS 45 degrees. Okay, so this is our answer. Okay, so after that, we just have to find z to the power 6. Okay, so by the De Morgan's theorem, we say that to find z to the power 6, what we have to do is the first thing is we have to raise the modulus to the power 6. This means that we're going to say root 2 to the power 6. After that, we have to take this 6 and multiply it with the argument. Okay, so this means that we're going to say 6 times 45 degrees. Okay, so this is it. Multiplying this, solving this, root 2 to the power 6, we're going to get 8 as our answer. Then CIS. Then here, we're going to get 6 times 45, we're going to get our answer is 270. Okay, so this means that this becomes our answer. Okay, so we want to change this answer back to this form. Since we are given our answer, our complex number in this form, let's change it back. Okay, so what you do is you just have to say 8 cos 270 plus I 8 sine 270. Okay, so this is how we do it. Okay, so now let's take a look at this here. Cos 270 is equals to 0. Okay, so this means that you're going to get 0 here. Okay, so it becomes 8 multiplied by 0 plus I. Then sine 270 is minus 1. Okay, so it becomes minus 1 here. Okay, so this means that if you multiply here, you're going to get 0. And if you multiply here, you're going to get minus 8i. Okay, so this means that we're going to get our answer is minus 8i. Okay, so this is it on finding the powers of a complex number. Okay, so this is it. We have just changed it to polar form first, and after that, we just raised it to the power 6 by the De Morgan's theorem. Okay, so this is it. Our second example is saying that find all cube roots of a complex number 8 cos 60 plus I sine 60. Okay, and sketch them on the Argand diagram. Okay, so the first thing is you're going to find all the cube roots, and after that, I'm going to show you how they look like on the Argand diagram. Okay, so the first thing is, let's say our complex number we are given is 8. Let's shorten it CIS 60. Okay, so this is our complex number. I just took this and shortened it. Let's say it's z. Okay, so the cube root means that you are finding the cube root of z. Okay, so finding the cube root of z, I told you that the first thing you have to do is just take this modulus and say 8 to the power 1 over 3. Okay, this is the first step. After that, you just have to say CIS. Then you are going to say theta. Okay, I remember the formula for the argument. I said that is theta plus 360k over n. Okay, so what we're going to do here, we're going to substitute theta is 60 plus 360k over our n here is 3. Okay, so this is it, and k is equals to 0, 1, and 2. Okay, so this is it. Okay, so to find our solutions, we're going to substitute k is equals to 0 first. Let's substitute k is equals to 0. Okay, so substituting k is equals to 0, we're going to get a to the power 1 over 3 is 2. Okay, so this means that is going to become 2 CIS. Then if you substitute 0 here, we're going to get our answer as 20. Okay, so this is the first root of this becomes our first answer. Okay, then the next thing is you're going to substitute k is equals to 1. Okay, so substituting k is equals to 1 is not going to change here. Okay, so it becomes 2 CIS. Then here, if you substitute k is equals to 1, it's going to give us 140. Okay, so this is our next complex number. We just substituted k is equals to 1 on this formula. Then the last one is k is equals to 2. We're going to substitute k is equals to 2. We're going to say that 2 CIS. Then you're going to substitute k is equals to 2 here. After substituting that, you can see that our angle becomes 260 degrees. Okay, so this is it on these complex numbers. Okay, so these are the solutions of our complex number. Our next duty is going to be drawing them on the Argand diagram. Okay, so let's write them down. Okay, so let's say the cube root of z is equals to, the first one is 2 CIS 20 degrees, and the second one is 2 CIS 140 degrees, and the third one is 2 CIS 260 degrees. Okay, so what we'll do is to draw this on a Gantt diagram, just draw something like this. Then just draw a 2 centimeter line from here, a 2 centimeter line here. This becomes the first one. Okay, so this becomes the first one, and it has to be 20 degrees here. this 20 degrees here. This line is 2 centimeter or 2 something, okay, 2 units, any units you want to use, this 2, and you find here, okay. Then the second step is you're going to use this 140, let's say it's somewhere here. You're going to take another line and draw it here. It is two units again, which this 2, okay. Then this angle from here to here, from this positive real axis, it has to be 140 degrees. Then this becomes our complex number. Then this next step is you're going to draw a 260. A 260 is somewhere here. This is the next one. Okay. So this angle from this side it has to be 260 degrees, and it has to be 2 here. Okay. So this is it. This becomes our complex number. Okay. So let's say this one is a W1, W2, and W3. Okay, so this W1 is going to come here, and W2 is going to come here, and W3 is going to come here. Okay, so if you draw well, you can see that these ones, these are 3 roots. If you join them here, they should form an equilateral triangle. Okay, so because there are 3, okay, so they form an equilateral triangle. Okay, so a cube root of any complex number, they form a cube equilateral triangle like this. A cube root of any complex number form a cube equilateral triangle. Okay, so if there is 4 here, it's going to create a square, and if there is 5, it's going to create a shape with 5 sides, and so on and so on. Okay, so this is it. This is how you find the powers and the roots of a complex number. Okay, so that was that on this. Make sure you subscribe so that you don't miss the next one, where we're going to look at how do we deal with polynomials and combine them with complex numbers. Okay, that was that. Please take care.